Alright, this is problem set number 2, and just as a reminder, this is a continuation of problem set 1. And problem set 1 was video 08G30, and if you recently saw this video, we left off on a problem where we have to predict the alkyl halide that would give us a chosen alkene as the major product. And so here I've written it as question number 1, or problem number 1. Draw the starting material that when treated with KOH gives the following alkene as the major product. And the first alkene we're going to look at is this one. We did part A at the end of problem set 1. We'll call this part B. And what was the strategy here? This is a product, and what they're really asking for is what kind of alkyl halide do I need to use when I treat with KOH. I give this as the major product. That's probably the key point. You want this to be the major product. And don't look at this. That's our next problem. So the strategy is, we know that the double bond is made between the alpha and beta carbon of the alkyl halide. So one of these, you can pretend it to be the alpha, and one of these the beta. And what I suggest is that you do trial and error. So for instance, what if the middle carbon was the alpha? Then our guess would be this. If we guess this halide, and I'll use a bromide, alkyl bromide, would I get, interesting, would I get this as the major product? So this is my guess, and here's my check. I'm going to give it to a classmate, and I'm going to ask my classmate to check this. Don't tell them this. Don't even show them that. Ask your classmate, what do I get if I use this as the alkyl halide? Now we have 3 beta carbons. We have 1, 2, and 3. 1, 2, 3. But this was actually a better problem than I expected. Let's take off the double bond, or the beta hydrogen off of the beta carbon on the left first. And I have this. Plus, what if I take the beta hydrogen on the bottom? What's going on with my hair? We have this. Okay. Are you getting this quick with your alkene products? All I'm doing is I'm drawing the carbon skeleton, and I'm putting the double bond between an alpha and a beta. Okay. Just beware that your beta carbon has to have hydrogens on it for you to make a double bond. Alright. And then the last one is this. Okay. And actually, they're cis and trans. So I drew, looks like the trans. I'm not going to draw the cis. I'll just label that we have a cis product, where the methyl group now is going up, just like the isopropyl group. There are 4 products here, 4 alkenes, and hopefully your classmate tells you that this is the major. Double check. So did this guess give us that as the major product? So this is a bad guess. Okay, and we'll just eliminate it. Yikes. Like I said, this was a little bit more challenging than what I had expected. Okay, so where's our second guess? Honestly, let me get rid of this because it's in the way. Okay, so we don't have an answer yet. We don't have an alkyl halide that when I treat it with KOH gives me this as the major product. Okay, so our second guess would be this. Let's put the bromide on this carbon, right there. Okay? Alright? You know the steps. don't show your classmate this. Ask your classmate, okay, what do I get now if I use this alkyl halide? There's 2 beta carbons, one on the left, one on the right. The middle one's alpha. Okay, I'm going to do this a little bit fast. Why don't you double check yourself, pause the video, and then when you come back, I'll show you the 2 products. 2 products? Maybe 3 products that I would get when I do this reaction. Okay. Give yourself a minute. No, give yourself like 4 minutes. Alright, pause it. Okay. Let me take off the beta hydrogen on the left, and I get this. Why was I worried that I would get more than 2 products, right? Because you have 2 beta carbons, shouldn't you be making 2 products? A double bond on the left and a double bond on the right? Well, what if one of those alkenes was cis and trans? Okay? And I know. Messed up already. Your double bond should occur right between the alpha and the beta, so that. What I realize here is that this is asymmetric, and we have trans. See, the bigger group is going here, and the bigger group is going there. And you compare the 2 groups on each carbon. So this is trans. So the cis version is this. Okay. And then if I remove the beta hydrogen off of the right, I get this. Okay. And then if I have to circle the major, it would be the tri-substituted, but we have 2 that are tri-substituted. So it's tri-substituted on the with trans. Okay. Is that the product we want? Yes. So the answer, and the only answer, when I'm asking for the starting material that gives me this product as the major product when treated with KOH, is actually this. Okay. So this is the only answer. Okay. Now, do you see how we answered the problem, but also we had a lot of practice? What was the practice? The practice was fill in the product. Fill in the product for this reaction, and fill in the product for this reaction up here. Okay, let me draw a dotted line so we can make sure that these products are separated. Okay. I can't get this all on the screen. Oh, let me just shift it all the way to the left. Right there. No, it's still not good. Right there. One alkyl halide gives us 4 products. One alkyl halide gives us 3 products. Okay. Alright. Oh man. Okay. Let me redraw C. And I'm gonna do this fast, okay? It's the same directions, so I'm gonna ask you to pause it and try your best to draw the starting alkyl halides. C is going to be this. And if you want to summarize the problem is this. If you want this as a major product, you want to treat an alkyl halide with KOH. What are the answers? It could be one answer, or it could be more than one answer. Okay. You know, in part B, we only had one answer. Okay. It's still entirely possible that there could be 2 answers. It just depends on the alkene you're trying to make. Okay. Do the trick. Pretend that the bromine or chlorine are on either one of these carbons, and ask your classmate to draw the products. Okay. Alright, when you're going to pause, and when you come back, I'm going to show you how I would do it in this case as fast as I can. Okay? Okay, we are back. I read the problem. I got to figure out the alkyl halide. I see that if I guess this, okay, I am going to put the double bond actually right here. Okay, so maybe I could draw this. This is how I would do it fast. So this is no good. So let me put the chlorine on the other carbon, the one on the left, here. And mentally what I'm thinking is, this is the alpha, this is the beta, and actually the only double bond I can make, so therefore it's the major product, is this one. I'm not going to guess this, because I would actually, for the major product, take off the beta hydrogen on the right to make this product as the major. And that is not what I want. There's only one answer, and it's this one right here. Okay. Let's move on. I want to do at least one mechanism problem for this problem set number 2. And that problem is going to be this. Draw products. Okay. Oh, by the way, since this is a continuation of problem set 1, I just want to remind us of the disclaimers. So here's problem set 1, and what were the disclaimers? The disclaimers were, this is only based off of the early videos, okay, 08B20, 08E20, and that's the case because I don't go over in those 2 videos more advanced topics. So some people may be familiar with these topics. If not, don't worry about it. You can still do these problems based on just these 2 videos. I'm not going to talk about anticoplanar conformations, and I'm not going to talk about a decision tree to decide whether you get substitution, elimination, or both. Okay. Watch these 2 videos, and you should be able to do these problems that we are going over in problem set 1 and problem set 2. Problem 2 for problem set 2 is this. Draw the products. I will tell you that, or in this problem they're telling you that they only want the elimination products. Although you could get substitution, but we're not worried about that in this problem set. State the mechanism. Okay, and you know that as either E1 or E2. And then, oh man, if we're going to draw multiple products, I think we should also choose the major. State the mechanism, and then draw the mechanism. Okay, I know I'm shorthanding the problem because I want to get through as many as I can in the half hour. The reaction is this. We have one reagent, and we have heat. Again, don't let things that aren't important distract you. You have heat, no big deal. You're not going to change what you've learned about E1 and E2. We have one reagent, methanol. What I know about this is that it could act like a base, and when it acts like a base, your atom that's doing the stripping, the atom that's grabbing the hydrogen or the proton, is this one. Okay, it's not anionic. Okay, so I'll just pull a note here because I know some students are a little bit confused. It's not this. That is not your base. This does not dissociate very easily. Even though it is protic, you're not going to lose this hydrogen very easily. It's not like it's ionic. So it's not as if you had sodium ethoxide, like this, with a sodium. Did I say ethoxide? I meant methoxide. So that's base. This is tertiary. It actually doesn't matter with eliminations whether you have a primary, secondary, or tertiary, for the most part. Let's label our alphas and betas. Alpha, beta, beta, beta. Draw the products. This is problem set 2, so I am going a little bit faster. We saw something similar in problem set 1. Fill in the products. Okay. You know that double bonds are flat, at least the atoms around the double bond. So I'm not drawing dashes and wedges, and I know that this is trigonoplanar, 120 degrees. If I take off the hydrogen off of this beta carbon, my double bond will go down, and I will still get the same product. It's identical. If you want to test it out, okay, if you draw it, you better make sure that the grader knows not to think that this is another product, because these two are identical. But I know that some students like to go ahead and double check visually all the possible double bonds. Okay, but for some of you, you'll realize that this is identical before drawing it. The last product is this. Double bond there. Okay, for this beta carbon. And then the major product is you circle either one of these, or you cross this out. Because there's only really 2 products, right? These and this one. I'll just circle this as the major. When I state the mechanism, they're all going to go through the same mechanism, okay, because you're really deciding based on that. This is a base, but what can I say about this? This is a weak base. The strong bases are the ones that are anionic. So this is a weak base, and it's going to hang out until the leaving group leaves on its own. So we're going to guess that it's E1. What do you know about an E1? E1 goes through a carbocation. E2 does not. Okay? Again, in blue, that's my answer, and maybe this purple that I circled. Everything else are notes for when I study. This is scratch work that the grader won't care about. Okay? They're looking on this side anyway. The mechanism. E2 is short. E1 is longer because there's a step where the leaving group leaves on its own. You have this. Oops, not plus. Arrow. Unimolecular processes go through a carbocation. So SN1 and E1 go through a carbocation. And where should I draw it? I'll draw it down here. Okay. I like to put every product that's made after each specific step. Okay. So I took care of that. But now I want to use the base. And I'm going to draw the base backwards. So the O is at least a little bit closer to what? To my beta hydrogen. If you're going to draw hydrogens off of this beta carbon, you have to draw all of them. And you do have to draw them because you want to explicitly show which proton you're removing. You want to show that this bond breaking and reforming as a double bond below. And that's it. Done. Okay, and this is again your major. We could draw the mechanism for the minor product over here. Okay, remember what they're called? The major product, or not the major, but the more substituted product is a Zaitsev product. The less substituted is the Hoffman product. You could draw the mechanism for the Hoffman product. It's identical to this, except you're going to remove the hydrogen off of this carbon on the end. Is that all I want to do? Probably it would be nice you may be asked on your mechanism to label the rate determining step, the slow step. Because there are two steps, we're choosing this as the slow step, and that's true. Under normal conditions, when they did experiments, they saw that this is a slow step. What does that mean? It means that you can only speed up the reaction by changing the concentration of the alkyl halide. Because you notice that if I change the concentration of the base, it has nothing to do with this step. Okay. Good. Number 3. What can we do for number 3? That's another predicted product. Let's see. Let's do this. Let's do another tert butoxide. Because in problem set 1, I was about to give the wrong answer, but then I caught myself. So this is T-BuOK. Okay. This is primary. It doesn't really matter if it's primary, secondary, or tertiary. What matters is that we be able to interpret this base and whether it's strong or weak. So again, I think of this as, and actually most textbooks write it like this. I'm not sure why the problem I'm looking at online writes it like this. Okay, potassium, because you have K plus and separates from the O T-butyl group. Okay. This is called a bulky base. And I am telling you that this is one of the most popular bulky bases. And if you have a base that looks like this, okay, that's not bulky. What I'm really looking for is how much branching you have next to the oxygen. So here you have 3 methyl groups. Over here, on this carbon here, we only have 1 CH2 group. So this is not bulky. Even if you have something like, maybe you have branching way out here. Okay, I would say this is not bulky either. For the most part, I tell my students to memorize that potassium tert butoxide is the main bulky base. There are others, but I typically don't teach the others. Okay, there's others. There's one called DBU. There's one called BBN. Yeah, there's a whole list. Just remember that the only bulky base for most professors is going to be potassium tert butoxide. Now, the thing is, the hard part is recognizing that, because what else is potassium tert butoxide? Some people draw it like this. See, 3 methyl groups off of a carbon that's connected to an oxygen, and they even put the counter ion. There's only 1 beta carbon though, and it's right here. Okay. I have a feeling that if you're rushing, you may draw this. This is no good. Right? We only have 4 carbons. Alright, so when people rush, they just plop a double bond on the last bond they see, or on the bond with the halide. That's not correct. There's only 4 carbons here. So your actual answer should be this. And there's no cis and trans, and this is the only product. So this is interesting because most people use the bulky base to aim for the minor product, what's called the Hoffman product. But the thing here is that we only get 1 product anyway. It's the only possibility, because there's only 1 alpha beta bond. So in this case, it didn't matter whether we used potassium tert butoxide or if we used something like, what do we call this? Propoxide, propyl oxide, as the common name. Okay, but what I'm saying is it's not bulky. Let me just specify that. Okay, because, and I'll put it here. What if we had this? I that, and I'm going to write it the way I usually write it. Okay. Let's see how fast or how accurate we can do this. I want you to draw the product and circle the major product. Okay, there's going to be more than one, I think, product. Circle the major product and tell me whether it's the Zaitsev or the Hofmann alkene. Okay, pause your video and come back in about 3 to 5 minutes. Okay. I'm not going to take any shortcuts because I almost made a mistake last time. The beta carbon on the left. What's this? But that is obviously cis. This bond can rotate. And so we could make the double bond while this methyl group is down to the southeast. Okay? In both cases, I took off a hydrogen on beta carbon 2. Alpha. Now if I take, beta carbon 1. Yikes. If I take off a hydrogen off of beta carbon 2, I get this. And there is no cis trans here. Okay. There's beta carbon 2. Yeah. I'm using a bulky base. And what that indicates to me is that it's easier for a crowded base actually to move this hydrogen off of the less sterically hindered carbon versus the one that's secondary. So we have a primary versus secondary. We know that primary is less crowded, and now size makes a difference. And we're going to strip off the hydrogen off of the less crowded carbon. Size doesn't make a difference when this is small, and you actually go for the hydrogen that gives you the more stable alkene, which would be this one right here. So a small base can hit either one with equal probability, but you would preferentially make the one that is more stable. Because we're taking off the hydrogen on the less crowded carbon, we end up making the less stable alkene the major product. Isn't that a little weird that the major product is actually the least stable? But it happens that way because, again, the bulky base is more likely to rip off this hydrogen to give us the less stable alkene, the less substituted alkene. The other part of my directions was name this type of alkene. Is it Zaitsev or Hofmann? This is the Hofmann alkene. It's the less stable, or you could even say the least stable alkene out of the three. This double N alkene. Okay. Kind of a cool trick, because you could probably guess that when chemists were first studying this reaction, they were always getting the Zaitsev product, and that makes sense. The most stable alkene is the major product when you use a regular oxide base like this. But when they started to use a crowded bulky base, they switched over. They switched it from this product as a major to this product as a major. Kind of cool. I don't know yet if I'm going to do a problem set 3. Problem set 1 and 2 are very similar. They're the similar types of problems, we're just doing different examples. So, again, I'm not sure if I'm going to do a problem set 3. It's possible. I'll drink a Red Bull and I'll be back with problem set 3.